Hello students, I hope you all are fine. So today we will discuss about the topic enthalpy. What do you mean by the enthalpy? Students, enthalpy means total heat content of the system. Total heat content of the system is known as the enthalpy. What do you mean by this total heat content? Students, enthalpy is denoted by capital H. It is denoted by capital H. If you are having some water at room temperature, try to understand what is the enthalpy. Let us consider you are taking water at room temperature. You know very well, at room temperature also evaporation takes place. Means it can convert it into the vapors. Means this water had some internal energy. This water had some internal energy. But students, if I want to run turbine with help of the steam produced by water, if I want to run turbine with help of the steam produced by water, so these vapors are not sufficient for moving turbine. Clear or not? Then student, what will we do? We will heat it. We will boil the water. We will boil the water. Means we will increase the internal energy. We will increase the internal energy. But students, if we boil the water, means at 100 degrees Celsius, it starts to boil. Is it possible to run the turbine with help of that one? Those steam produced by boiling only. Those steams are also not sufficient. Clear? Then we need to apply some pressure. We need to apply some pressure. Okay. Then students, we will apply some pressure. Then there will be change in volume also. Okay. Means we will do some work. We will do some work. Okay. Then students, enthalpy means here the internal energy which is possessed by the system, plus we do some work on that. That is pressure into volume. That this total heat content of the system now, this total heat content is known as the enthalpy. So what is the enthalpy? Enthalpy is equal to U plus PV. This one is the enthalpy. Enthalpy is the total heat content of the system. It is clear to you or not? What is enthalpy? Any doubt in this? Okay. Then students, enthalpy is a state function. Means it depends only on initial and final state of the system. It is an extensive property. means it depend only on the quantity or amount of the particles present in the system and size of the particles present in the system, means it is an extensive property. First one, what is enthalpy? Enthalpy is the total heat content of the system. Okay, it is the sum of the internal energy and product of pressure and volume. Clear or not? It is a state function and it is extensive property. Now students, you know very well, according to first law of the thermodynamics, del V is equal to Q plus W. And you know very well, del U is equal to Q. I can write W in this way, Q minus del V. W is work done. We have done in previous class. This is work done. Okay. Then students, if we have constant volume, isochoric process if it is, at constant volume, what will happen? Del V change in volume will be 0. Then I can write del U is equal to QV. Means internal energy is equal to the heat produced at constant volume. But student, it is not possible to proceed all the reactions, all the chemical reactions at constant volume. It is not possible. Okay, then what will happen? If we do the reaction at constant pressure, then what will happen? According to first law again, del U is equal to Q minus P del V. I can write, okay, because here pressure is constant, so I can write it QP. Okay, then students, if our initial internal energy is U1, internal energy at initial state, this is, let us consider U2 is internal energy at final state, V1 initial volume, and V2 is final volume. V2 is final volume. Okay, so from here, students, I can write del U is equal to U2 minus U1, final internal energy minus initial internal energy, is equal to QP, heat at constant pressure, minus P, pressure is constant here, then del V means final volume minus initial. Can I write in this way? Okay, then U2 minus U1 is equal to QP minus P into V2, PV2, here minus minus plus PV1. If I write QP one side, then U2 minus minus, this is minus. If I take in opposite, then it becomes in plus. then minus u1, this is in plus, in opposite side in minus. Then students, u2 plus pv2, can I take minus common from here? Then minus u1 plus pv1 is equal to qp. Okay, so qp is equal to u2 plus pv2 minus u1 plus pv1. Students, I already told you that what is enthalpy. Enthalpy is u plus pv. Okay, so from here u plus pv2, I can write h2, I can write h2. So h2 minus h1, so I can write it h del h is equal to qp. Del h is equal to qp. Clear or not? This is change in enthalpy. This is change in enthalpy. Del h is equal to qp and del u is equal to qv. Del u is equal to qv. Clear or not? So from here, this is heat absorbed or released at constant pressure. And this one is heat absorbed or released at constant volume. At constant volume. So students, this is change in enthalpy. Change in enthalpy will be equal to heat absorbed or released at constant pressure, and in change in internal energy is equal to the heat absorbed or released at constant volume. It is clear to you or not? Yes. Then students, this delta H, it may be positive or negative. When it will be positive, it will be positive for endothermic reaction. For endothermic reaction. Because in case of endothermic reaction, system has already some energy, plus it absorbed some more energy. It absorbs some more energy. Then total energy is going to increase. Total energy is going to increase. If heat is absorbed by the system, then it is known as the endothermic. Clear or not? Then it is known as endothermic. And if heat is produced, then it is known as the exothermic. So for exothermic, it will be negative, and for endothermic, it will be positive. It is clear to you or not? Yes. Students, if we talk about the ideal gas, then you can also write this one. PV is equal to nRT. Then you can apply this. Here you can apply. This is QP. Here you can apply value PV is equal to nRT. So for first one here, we can write N1 RT. If you are taking constant temperature, then number of moles are exchanging here. Here you can write N2 RT, and then you can do the same expression. Clear or not? So students, this is all about the enthalpy. First of all, you should know that what is enthalpy. Enthalpy is the heat content of the system. Okay, already which energy is present in the system and which amount of energy is absorbed or released by the system. Okay, means it is the total heat content of the system. Here it is at internal energy plus product of the pressure and volume. This is the mathematical expression for this one. It is state function. Because it is state function, so we can write it H, del H, means in this case final and initial state. It is extensive property. Then I can write it in this way. This one is the internal energy expression. If you are having constant volume, then you can write del U is equal to QV. Okay, but all reactions are not possible at constant volume only. Then sometime we can take constant pressure also. If you take constant pressure, then you can write first law of thermodynamics in this way. Then here this is change in internal energy, means final internal energy minus initial. So U2 minus U1. This is QP minus P. Here again this is change in volume, means V2 minus V1. Okay, then solve it. U2 minus U1 is equal to QP. This is minus PV2 minus plus PV1. Okay, then U2, this in this side it will be in plus and it will be in minus. Then you can take minus common from here. Then QP is equal to U2 plus PV2 minus U1 plus PV1. You know very well U plus PV. It is enthalpy. So you can write it H2, and this one you can write it H2, and you can write this one is H1. So H2 minus H1, you can write del H, and del H is QP. So change in enthalpy is heat at constant pressure, and change in internal energy is heat at constant volume. Clear or not? Yes. So this is all about the enthalpy, students. Thank you. Have a nice day.